All right, 11.4, equation of a parabola from Focus and Directrix. So this is a little bit different. We've talked about the equation of parabolas before. And in those situations, we've done a few different things. And I'm going to just review those with you guys real quick. We had standard form. And in standard form, we said, hey, y equals ax squared plus bx plus c. And this was great for finding the y-intercept. And then we had root or factored form. And this looks something like this. Where, remember that these were your roots or your zeros. And then we also had vertex form. And vertex form looked like this. And what was nice about this one was that, of course, it gave you your vertex. Okay, so the reason why I'm recapping all of those today is because we're going to end up with this form today. Vertex form. It's just going to look a little bit funky because now we're going to start off with different information. Here we start off with the vertex and we could write the equation pretty easily. Or here we start off with the zeros, or here maybe we just start off with the equation and we get the y-intercept, or we start with a factored form and we multiply together and we get standard form. But now we're starting off with something new. We're starting off with things called the Focus and the Directrix. Focus and Directrix. So let's talk about those. So a parabola is actually defined as the set of all points that is the same distance from its focus, or we could even say focal point, and directrix line, directrix. And so what is that? Well, a focus is just this like point in the center of a parabola here, and it's a point that is the same distance or equidistant. That's a good vocabulary word right there, equidistant, to any point on a given parabola. Notice they label it here as x, o, y, o, as the distance from the point to that directrix line. So here's the idea behind this. Regardless of where I put this point along the parabola, I should be able to draw it anywhere on here. Boom. Let's just say right there. And that distance there should be the exact same distance straight down to the directrix. These two distances should be exactly the same if it's actually a parabola. So that's what the focus is. That's how it's defined. And what's really interesting about this too is if you were to actually have some actual parabolic shape, and you maybe you had some like light rays shining down, like you may see this in like light bulbs and stuff like that, and you had some light rays shining down, they would all bounce and hit this focus. That's what's pretty cool. So in headlights that you've probably seen, or in flashlights, they have this bowl type shape or this parabola type shape inside them, and the light bulb's actually right here, because then when the light comes out, it shines out and it reflects perfectly forward. And that's kind of how a flashlight is created. It's pretty cool. So that's how kind of parabolas are used all the time. It's in lights, headlights, flashlights, all that kind of stuff. And that focus point is really important. And then on the other side of the focus, there's some directrix, some line. And this is a line that always runs perpendicular to the given axis. So here we have, the axis of symmetry. Axis of symmetry of a given parabola, where any point along the parabola is equidistant to the directrix line and the focus point. Again, these two distances here, regardless of where you are on the parabola, has to be exactly the same. So, because those two distances are the same, we can actually write a formula with just those two things. I'm going to show you how we can do that here below. So to start off, I'm going to call this distance here L. I'm going to call this distance here M. And if those two if those two distances are the same, then we can start off by saying that L has to be equal to M. And since we know the distance formula here, because it says using the focus and directrix defined above, and the distance formula, let's try to create the formula for the parabola. So since we know the distance formula, let's write the distance of L and the distance of M using A and B, X and Y, and then this line Y equals C. What that means here is that this point, wherever that line connects, wouldn't this be X, comma, if Y is C, and this would just be C. And here, I'm going to say you could just call this X and Y for now, for this equation. So let's first define the distance of L. Remember, here's a distance formula. So it's the x2 minus the x1. So let's just say x minus a squared, and this is all underneath the square root, plus, now there's 2y, so this would be like y minus b. And this is equal to this distance m. Let's also use the distance formula, square root. And here, the x's are the same, so we're just going to write x minus x squared plus, and we could write y minus c, right? Y minus c. Okay, so for the rest of this part, I'm just going to be doing some basic algebra to try and clean this up. My whole goal, actually, is to get the y all by itself, because then it would be in vertex form, just like it is here. Now, it won't look exactly like this, but essentially, it's going to be this. In fact, you could probably already recognize here. Notice this right here, x minus h squared. Take a look. I kind of already have that part. So I'm going to get it all so that it looks very similar to this, and we'll do it together. So let's see. First thing I recognize is that x minus x is 0 and 0 squared is 0. And then that means that I just have something squared underneath the square root. Well, the square root and the square cancel each other out. So what I can do right off the bat is I can square both sides, and that would get rid of this square root symbol here. So I have x minus a squared plus, and I'm not going to do it for this one, but let's go ahead and expand this thing out. It's just y minus b squared right here, but let's go ahead and just expand it out. It would be, if I was the box method or FOIL, it would end up being with y squared minus 2by plus b squared equals, and remember, all I have left over here now, we said this square canceled out with this square, but then I squared both sides to get rid of the square root. So now all I have over here is a y minus c squared. And again, I'm going to just expand that out. So I would get y squared minus 2cy plus c squared. Now, hopefully at this point you recognize why I expanded it, and that's because I have a y squared on both sides. If I was to subtract y squared from both sides, this would just zero out. So I don't really need these. They kind of cancel each other out. Okay. The next thing I can do is I can get this negative 2by to the other side by adding 2by to both sides. And I can get rid of this c squared by subtracting c squared. So that cancels this out, and that cancels this out. So let's rewrite what I would have here. I'd have x minus a again squared plus this. Couldn't I write this as b squared minus c squared equals, and over here I could actually, if you think about this, I'm going to just combine these. They both have a 2 in them, they both have a y in them, so I could actually write this, I could factor out the 2y, and I would just have b minus c. Okay. Another thing that we're going to use here is we're going to use some properties of special products or special factors that we know. When we have a perfect square minus a perfect square, we can expand that like so. So this is x minus a squared, and this is actually b plus c and b minus c equals 2y b minus c. Alright, so maybe you can see how we're going to eventually get this y all by itself now. I can just divide everything by 2 b minus c. And I could do it as one big fraction, or I could break it up and do it as two fractions. I'm going to break it up and do it as two fractions. Because b minus c cancels out, 2 and 2 cancel out, b minus c and b minus c cancels out, and so here's what I have left. I'm going to rewrite it so the y is actually in the front, because over here all I have is the y. So let's just put the y in front, y equals, and then I would have x minus a squared over 2 times b minus c, plus all I have left in this part here is b plus c over 2. I'm going to put parentheses over there so we remember that we have to add those before we divide by 2. Well, I know it doesn't look exactly like it, but really this is vertex form. So let's take a step back. Let's go back and think about what vertex form is. It's just multiplying by something times x minus h squared plus some other value. Well, here we're not multiplying, we're dividing by something, but essentially that's the same thing. Whatever this number turns out to be, that's just like multiplying it by the fraction or reciprocal of that number. And then we're just plussing some number here. And so what we've discovered is that if all we knew was the focal point and the directrix, we could plug that in and we would actually get the vertex form of the equation. So let's go to the next page. So it turns out all of that was just a fancy way for us to prove that these two are formulas of or forms of the equation for a parabola. So notice that there's two of them. There's one where y equals, this is what we just found, and there is such thing as sideways parabolas, and so those can look like this if I just sketch it for you. Here's your xy, and here's your directrix. I'm just going to say dir for directrix. This is just a quick little sketch to show you can have sideways parabolas, but in order to do that, it has to be x equals the equation. And notice kind of everything flips here, right? Instead of x minus a, it's y minus b. Instead of b plus c, it's a plus c. And instead of b minus c, it's a minus c. So these are the two forms that you can use. But a really easy way to tell which one you're using is just by looking at the directrix. If they tell you the directrix is x equals a number, then use the x equals the equation. If they tell you the directrix was y equals a number, like we did on the previous page, then use the y equals. That's all there is to it. But it's just now we have to account for the fact that there could be sideways parabolas. This is one that opens to the negative, so this would actually be a negative out here or down below of the y minus b squared. And then there's also ones that open to the right. And if this is your directrix line, then your focus would have to be somewhere over here so that it's the same distance from the parabola as the directrix. Just a little quick sketch of it. Not really important because all we really need to do here is be able to write the equations for the parabola with a focus and a directrix. And so we're going to do example 1 together. The first thing that I do is I just copy down the appropriate equation. This says x equals -3. That means I'm going to be using this thing. So let's just copy it down. X equals y minus b. It may seem redundant to copy it down, but it's really good strategy, a useful skill. 2 times a minus c plus a plus c over 2. All right. Well, now we got to identify all the parts. So the focus is your a and your b, and the directrix is your c. And literally all we have to do now, guys, is just plug it in. So I'm going to do this all in blue. We got x equals y minus b. My b is 2, so this is y minus 2 squared over 2 times my a is -7 minus my c is -3 plus my a again is -7 plus my c is -3 all over 2. Alright, so let's just clean it up. What is this really? This is like saying x equals y minus 2 squared. And down here, ooh, we got some weird negatives going on, so that's like a double negative. So this is -7 plus 3. That's -4 times 2. That's -8. Over here, -7 and -3, that's -10. Divided by 2 is -5, so I could just say -5. And if you look, this is really like vertex form. This is like saying, it's like your a value being -1/8, because you're dividing by -8, and then your k value is -5. And you actually could see where the vertex would be too. So you got the equation right away. If you needed to graph this, you could, no problem. Alright, practice number 1. I want you guys to give it a shot. Try it on your own, and then check back when you think you're done. Okay, so again, I wrote out the equation like I said, and then from there I just plugged in my a, my b, and my c, and plugged it all in, and then I just simplified, and I got y minus 3 squared over 18 minus 1/2, where the -3 and or the +3 really, and the -1/2 would be your h and your k, or your vertex. Pretty easy once you have the formulas. Again, all you got to do is identify which of these two formulas to use first. Again, if the directrix is y equals a number, then you would use that. But like in these two, it's x equals a number, so you're using the bottom one. All there is to it. See you guys on the next video.